Hello viewers, welcome back. This is MIJ TECH HACKS and this is MIJ Technologies, and today we are going to cover another topic or another subtopic in our journey, and that is the for loop. We are still tackling our module 3, and that is control flow. So welcome back. We've spent sessions on the while loops, and I want you to genuinely feel comfortable with those before we move on. But today we are starting with a brand new kind of loop, and honestly, this is what you are going to use most in the rest of your programming journey. It is called the for loop, and today we'll learn the range. We will loop through the actual list of real items, and I will show you a neat little tool called Enumerate that gives you a running number alongside each items for free. So let's go in it. Let's dive in it. Why do we need to study this new kind of loop, the for loop? The quick question before we touch any syntax: if the while loop can already repeat things, why does Python bother giving us a second loop at all? Here is the honest answer, guys. While the while loop, you are responsible for everything. You set up a counter, you remember to update it, and you write the exact condition that stops it. That's powerful, but it's also more work than it needs to be for one of the very common situations. When you already know exactly what you are looping over, maybe it is a list of 5 fruits, maybe it's the numbers 1 to 100. In those cases, you don't want to manually manage the counter. You just want to say, for every single item in this thing, do something with it. That's exactly what the for loop is built for. The core definition: a for loop goes through a sequence. That could be a list, a string, a range of numbers, basically anything you can count through one item at a time, and runs its body once for each time inside it. And unlike the while, you usually know in advance exactly how many times it is going to run, because it is tied exactly to how many items that are in the sequence. So that's all about the for loop. In our definition in the notes we have, a for loop iterates over a sequence, a list, a string, or a range of numbers, or any other iterable, and runs its body once for each item. Unlike the while loop, you usually know exactly how many times the loop will run. So for those who don't know where this is the PDF notes that we are using. For those who don't have access to it, you just need to go to our YouTube channel, which is MIJ TECH HACKS, and then on our where there is links, you go to where there is more links. Then there is my GitHub portfolio, there is my LinkedIn account, then document files for courses. When you click document files for courses, it will take you directly to where these PDF notes that we are using to follow along they are located. So today we are going to cover extensively the for loop, and then appreciate how it operates. So let's open our VS Code and try to do some practical live coding. So we have covered the core definition of the for loop, and we have appreciated that for the for loop you need to know the number of times the loop is going to iterate over a sequence of an iterable. So we are going to go further to generating numbers on demand, and that is the range function. So the most common companion to a for loop is something called the range. It holds the job to generate a sequence of numbers for us to loop through without us having to type each one by hand. For example, we might have something like, for I, I'm using the notes that you will have to come up with this lesson. So I hope that someone opens that PDF and then follows along, because every example we are doing here is in our notes, and I've already shown you the platform on which the notes are. So for I in range 5, so we are using the for loop, and we said that the most common companion to a for loop is something called the range. Its whole job is to generate a sequence of numbers for us to loop through without us having to type each one by hand. So for range in 5, so this one gives us a range in which we are going to iterate over. So we shall have print I. For I in range 5, print I. Let's try to run our VS Code, or to run our code in the terminal, and we see what comes. So because range 5 exists, what does the word range 5 means? It means that we are going to start counting from 0 and end on the number before the specified number. For example, if we have 5, we are going to start counting from 0 and end on the number before it, that is 4. So it will count from 0, it will give you numbers which includes the 0, 1, 2, 3, 4, and then it will stop on 4, because range tells us that start counting from 0, but include only numbers that are less by 1 on the exact number that you have put in, or on the number that you have put in into the range function. So we shall expect the output to be with 0, 1, 2, 3, and 4. So when you run this and you get 0, 1, 2, 3, and 4, now here is the part that trips up every single begin. So listen closely. Range 5 gives you 5 numbers starting from 0 and stopping before it reaches 5. It does not include 5 itself. That's what we call the stop. The stop is excluded rule. That's what we call the stop is excluded rule, and it applies everywhere in Python, not just here. You will see this same idea again with lists and strings later. So if you ever want the numbers 1 through 5 instead, you actually need to put the range to be like 1 to 6. If you ever want numbers that when there is no 0, and you must give it the starting point and then the end point. That is when it will give you numbers 1 to 5. So giving Python both a start and a stop. For example, if you have something like, let's get rid of this. If you have something like for I in range 1, 6, print I. So here we have given it the start and the end, meaning that it will start at 1 and end on the number before 6, and that will be 5. So we expect it to print 1, 2, 3, 4, and 5. So you need to cut that rule. You need to cut that stop is excluded rule, which applies everywhere in Python. So here that gives 1, 2, 3, 4, and 5. See what happened. Let's see what happened here. So that's why it gives us 1, 2, 3, 4, and 5. So that's what happened. We told it to start at 1 and stop before 6, which conveniently lands us exactly on 5 as the last number printed. Getting this stop is excluded rule into your bones now will save you from a genuinely common off by 1 bug later. There is a third optional piece too, a step which controls how much we jump by each time. So let's try to go through that. This optional rule that controls how much we jump by each time. So let's get rid of this and then tackle it. So for I in range, I think you have ever come across this 0, like 11, then 2. Print I, print I. So we have our code like this. So this says start at 0, stop before 11, but jump 2 each time, or jump 2 steps each time, giving us 0, 2, 4, 6, 8, and 10. And here is something clever. That step can be -2, but let's count that lets us count backwards. So let's try to see in our terminal. So that last part is the number of steps it will be skipping. So we expect it to print 0, 2, 4, 5, 8, and 10. So that last step can be -2. Let's try it with the negative part and then check. For example, if we have our range as 10, it is going to start at 10, then it will skip, it will stop at 0, because we are going to be counting by negative steps. So we expect it to print, so it will start at 0, step down by 1 each time, and stop before we reach 0, giving us 10, 9, 8, all the way up to 1, but it will not print 0 because of our exclude rule. So notice 0 itself never prints because the stop is always excluded. Counting down is just like counting up. So let's print on our terminal, then see that. So you see that it will count 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1, excluding the 0. So let's try to put the step as -2. It will be skipping 2 each time. Let's try to put it as -2 and then try to print to the terminal. So we appreciate that it will be printing. It will start with the 10, then 8, then 6, then 4, and then 2. It will not print the 1 and 0. Why? Because when it prints 2, the next one, the next digit that it will print will be 0, and 0 is excluded with our rule. I hope someone appreciates so far where we are and appreciates the use of the for loop. So we are going further in our notes, in our PDFs, looping over an actual list. So the range generates numbers for us, but very often you already have a real collection of the things, the actual data, and you want to visit each item one at a time. That's where the for loop really shines. So let's have our examples here. For example, we have flutes equals to I'm using here, don't take much attention on this, because we are going to know what lists are, and we are in the later topics of variables. So we shall know what lists are and what dictionaries are, but for this you need to just type this syntax by saying that anything that is any data structure that has the opening blocks as this formula are referred to as lists, like as we shall see. So a list is something that holds things in an ordered manner. Lists are ordered. So you need to just know that in your brain. So we have a list containing, let's say that it is a basket containing, and the basket is enclosed, and the fruits are enclosed in this basket. So So the basket is containing fruits like the apple, then also it contains the bananas, then it contains the mango, it also contains pineapple, and those are the fruits that our basket is containing. Our basket is containing, and we have put them in the list. So if you want to iterate over these items that are in the basket, we shall say that for fruit in fruits, print fruit. So read this out loud, exactly like English. For each fruit in the list of fruits, print fruit. Python reaches into the list, pulls out the first item, which is the apple, temporarily calls it fruit for this one pass through the loop, runs the body, and then moves to the next item, banana, and does this all again right through the pineapple, which is our last item. No counter, no manual index tracking, no range that is even needed here. Python handles every bit of that bookkeeping for you behind the scenes. Notice the variable name that is fruit. It is singular, while the list itself is fruits, which is plural. This is not a rule Python enforces. It is just genuinely a good habit because it makes your code read naturally. For a single fruit in the whole collection of fruits, that small thing, but it makes it a real difference to how readable your code is 6 months from now as you are getting back to it. So you need to be very careful. You can even say for each item, this is just a variable that anyone can use. Because they are fruits, I can say for each fruit, or for fruit in fruits, print fruit. So we shall have it as banana. We shall have it will print these fruits in the order like as we have entered them. So it will print apple, banana, mango, then pineapple. So it will print apple, banana, mango, and lastly pineapple. You see, observe that there is something, there is an error. I think we forgot to close the quotation. Let's try to see into our program. When we track, I think we forgot, we typed something inside the pineapple, and when we run, it will give us apple, banana, mango, and then pineapple. Apple, banana, mango, then later pineapple. So that is it, and I think someone is appreciating the use of the for loop. So we shall go to enumerate, getting the position and the value together. If you wanted to get something like 1 is apple, then 2 is banana, and then 3 is mango, then 4 is pineapple. How do we do this automatically without having to manually name or give or assign numbers to these items in the basket of fruits? How do we come up with this? We use a function called enumerate that helps us to get the position and the value together. So let's try to use this in our VS Code. So we shall have it as, so sometimes just having the item itself is quite not enough. You also want to know its position in the list, maybe you are numbering a list for display, or you need to know exactly where an item sits. That's what enumerate gives you. So we have, let's try to go back from our fields. Let's try to go back from our fields before I write this. So we have that, we have this as our list. We have our list of fruits, that is pineapple, apple, banana, mango, in that order. So we have for index, if you want to get if you want to enumerate, we say that for index, because that is now the numbering index, then fruit in enumerate. This is when we use enumerate if you want to assign numbers. In enumerate fruits, this time we are not going to say in fruits, we put that function of enumerate for it to be able to count or to assign positions by numbers. We shall say print. We shall use the f strings to assign first the index and then the fruit. Print first the index, and then after the index we shall have a separator, which is a full colon, and then print the fruit. So that is it. Let's try to run our terminal and then we see. So this will print in the zero position there is an apple, and then in the first position, which is the one, in position 1 there is banana, then in position 2 there is mango, and then in position 3 there is pineapple. Notice that it's counting. If you use enumerate as a function, its counting starts with 0. But how do you do it if you want to start counting at 1? Because we know that humans, their counting starts mainly at 1. So here is what is actually happening. If it will print 0 apple, 0 as apple, then 1 banana, then 2 mango, and then 3 pineapple. So here is what is actually happening. Enumerate wraps around our lists, and for every single item hands back a pair of values instead of just one, the position number and the actual item. So that's why we write for index, then fruit in enumerate fruits, with the 2 variable names instead of just one, meaning that the first variable name will be for the index, and then the second one will be assigned to the fruit. So we are unpacking that pair in two separate variables, one in one go. So index is catching the position and fruit is catching the value. And notice the index starts at 0, not 1, same as everything in Python we've seen so far. The range included apple sits at the first position, which is position 0, then banana at position 1, and so on. If you ever needed to display these starting from 1 instead, for a nicer looking numbered list for a real user, you will simply write index plus 1 inside your f string. Small adjustments, but good to know at that stage. So let's try to put index plus 1 so that it starts counting at 1. So we shall just need to say index plus 1 so that the index starts counting at 0. So we just need to just change something here in the expression so that our counting starts at 1. Let's try to see. Let's try to print to the terminal and see now. We expect it to print 1, 2, 3, and then up to the last item, which is the 4th item, and that's the pineapple. So it gives us 1 apple, then 2 banana, and then 3 mango, then 4 pineapple. So that is it. Or someone would even say, assign the starting integer in the formula of enumerate. But even this one is very okay. I don't want to give you very many things to absorb because they might later confuse you. So just updating here in the downer part by changing the expression gives us the starting value. So that is it. So that is what enumerate is. We are going to build this together live. We have an exercise which is exercise 8, which is the multiplication table. So the task is to ask the user for a number, then print its multiplication table from 1 to 12. Let's do it. So if you have something like n is equal to, because it is a number, it must be int. We covered that in the first tutorials. Input, we covered also the input function. For those who haven't gone there, please visit them and then you come back to appreciate the process. Enter a number. It will tell you that enter a number. So you want to print its multiplication table from 1 to 12. So it will prompt the user to enter the number, which is that. Then print shall have the f string multiplication table for multiplication table for that number which you have entered, and we put it into that, and then it is going to be generated down here. So let's try to, that is just the heading. This is just going to mark as the heading. So for us to come up with the multiplication table, we shall have it as for I in range 1 13, meaning that it is going to generate numbers starting with 1 and end at 12. That last number before the number that is included. I think that clicked into your medulla oblongata. So we shall have it as result. The result is equal to n multiplied by 1. That is the formula. N multiplied by 1. N multiplied by 1. So down here we shall give it for I in range. For example, if you want to include 12, we shall use 13. That's why we have, because we are interested in 12. We want to print the multiplication table from 1 to 12. Because we are interested in 12 itself, we shall increment it so that it becomes 13 in our range, and then we'll be able to print the result. So we shall have to print what the multiplication table will consist of. So we shall use our f strings and then come up with this print. So we shall print the f string, which is that number you have said, which is the number which is 12. Then we shall multiply it with the I, the first I, which will start with 1, then 2, then 3, then 4, like that. So the I, then 2. And it will be giving us, the value as the result. The value as the result. To be giving us the value as the result. To be giving us the value as the result. So we shall have it as 12 multiplied by 2, then multiply. When you multiply by 1, so this was not 1, it was I. It was I. This was I. So that is the result. So we shall have it as 12 multiplied by 2, 12 multiplied by 3, 12 multiplied by 5, like that, like that. So let's try to print and see. So when they told us to enter the number, we shall enter the number as 12, and then it gives us 12 multiplied by 1, it is equal to 12, 12 multiplied by 2, 24, and then up to 12 multiplied by 12, which is 144. So that's how we print the multiplication table, and that's how it gets printed. So to walk you through this, range 1, we have used range 1 to 13. Let's try to see here. We have used range 1 to 13, and I have explained that. This gives us 1 all the way through 12. Because remember, 13 itself gets excluded. Each pass through the loop, I becomes the next number in the sequence. We multiply it by n. We multiply n by that value, which is I, and then print the line. That little I to 2 inside the F string, that's the formatting trick that pads the number out to 2 character width. So the single digits and the double digits line up neatly in a column instead of looking ragged. Purely cosmetic, but it makes your output look genuinely professional. So with exercise 9, we have finding the minimum without using the max. Finding the minimum and the maximum without using max. So let's try to go through exercise 9 and then see. So the task given a list of numbers, find the biggest one, but without using Python's built-in max function. We are going to build the logic ourselves, because this is actually one of the most classically taught algorithms in all of programming, and you will see this exact pattern show up in real interviews. So let's try to have something like numbers is equal to, they have told us that given a list of numbers, and this is the list of numbers that they have given us in our document. For those who don't have the document, it is what I'm using here to come up with these examples. So we have our numbers that are given, that is 34, the numbers that is 34, 78, 12, 95, 56, 23, then 88 and 41. So they want us to get the maximum, but without using the max built-in function for Python. So we shall have it as maximum. We shall create a variable called maximum, and then call it numbers 0. So we shall have it as for number in, we shall say for number in numbers, or someone could use any other, someone could say for num in numbers. In numbers. What are we going to do for each number in numbers? We shall, if the number is greater than maximum, so we are going to be comparing, starting with, why have we said here? You will appreciate that in lists, when we reach at lists, we shall look at accessing contents that are in the list, and we use these box brackets to access contents in the list. So when we put 0, it means that we are accessing the very first item in the list, and that will be 34. So we are going to be comparing every number, and every number that is in this list we compare it with the first one, which is 34. If that number is greater than that first one, then it will be the maximum number. So we shall have it, if number is greater than maximum, then what will we do? We shall say that maximum equals to number. Maximum is equal to that very number that is greater than the first one, which is 34. So it will be equal to number. Maximum will be now assigned to a new value, which is that number, and then we shall later print the maximum after the loop. So we shall now print, we shall be able to print using the f string. We shall print number, shall print numbers, which is numbers. This is just for your formatting. So attach the numbers which were given. So those will be the numbers, and then to print the maximum, we shall have it as our f string. We shall print maximum, which will be the number that the new assigned value for maximum. So that is it, because now Python will update the maximum. At first we gave the maximum number, so you can even pick 41 and then traverse through the list. We shall see that when we put 2 or even 5 or even what, the maximum number will remain the same, because Python will traverse through the whole list and then give us what the maximum number is. So let's try to print to the terminal and see. So we expect it to be 95. You see? So given those numbers that are in the list, the maximum is 95, and we have not used the max function, which is the Python is built function. So here is the actual logic, and I want you to really understand the reasoning, not just copy it. We start by assuming the every first number in the list. You can even use let's see, you can even use 2. Again, you can compare it using 12. If the maximum number is 12, then for numbers, for it will start comparing with 34, then goes to 78, then assigns it to 12, then like that. So let's try to see. Even if you have given it position, it will still print 95, because Python will start with 34 when it is comparing. The for loop will move with it will start with the first and then go on comparing. The one that finds the biggest, it will be the maximum number. So you see it as 95, and you appreciate that. Even if you say that let me put 5, again it will go on comparing and then give us 95. So that is it. And I hope someone is appreciating. So that is the logic, which is we start comparing with numbers. You can say, like as I've put 0, you start comparing with the first number, which is 34, is the biggest one we have seen so far. So that's our starting point, which is our starting guessing point. Then for every number in the list, we ask one simple question: is this number bigger than the one I have found so far? Because so far we have seen 34 as the first number. So we go on comparing. Is this 34 bigger than the one I've seen, which is 34? So it is not big, it is equal. So the maximum is already assigned to 34. Then we go to 78. Is 78 bigger than 34? If it is true, then the maximum becomes 78. Then we go to 12. Is 12 bigger than 34? No, the maximum still remains 78. Then we go to 95. Is 95 bigger than the 78 that I've seen? Yes, 95 is bigger than. So the maximum is becomes assigned to 95. Then we go to 56. and then we ask ourselves, is 56 bigger than 95? Not really. So the maximum remains at 95. Then to 23, to 88, and then 41. So by going through that, we appreciate that all of the other numbers that are going on are not bigger than 95. So the maximum remains at 95, and by the time the loop finishes, we shall have our maximum number as 95. So that is it. So by the time we finish, whatever sitting in the maximum genuinely is the biggest number we have ever encountered so far, because we compared it against literally every single one. This is called the linear search or the running maximum pattern, and it is the exact same idea Python's own maximum function does internally. We've just written it just by hand, or we have just written it manually, so you actually understand what is happening instead of it being a black box. Wrapping up today's session, this part 4 is done today, was a big one. We've learned why for loops even exist alongside the while loops. We've mastered the range, including the crucial stop is excluded rule. We looked through an actual list of real data, and we picked up enumerate for getting position and value together. Then we built 2 solid exercises, the multiplication table and finding a maximum the hard way or the manual way. The real algorithms work under the hood. Then later in part 6, or in the next part, we are going to in the part 5, because I think in the next part will be part 5, we are staying with the for loops but moving to a new types of data, looping over individual character of a string and looping over the dictionaries, keys and values. That will bring our membership operator in from part 3 or from part 2 back into play 2. So that is it, and in reality it will be a satisfying way. See you in the next video. This is MIJ Tech Hacks, this is MIJ Technologies, and I want you guys to visit the notes and then prepare for the next part. See you. Innocent Junior Mkwaya, copyright 2026, MIJ Tech Hacks, MIJ Technologies. Goodbye.